I will quickly go through the concepts, right? I think the same concept we have discussed in our open session also. But yeah, anyway, I will quickly recap those concepts, and then, as usual, I have come up with some questions which we have already asked in previous end-term quizzes. Okay, so we will try to solve these questions. Okay, so let be fine to all of you.
Yes,
Yes,
sir.
Yes,
sir.
yes, sir. Yes, sir.
Okay, so are you done with week 9 and 10?
Yes, sir. Week 9 and 10 is over.
Over,
Mm.
right? So, no, no, my question is from your side, not from our.
No, yes, sir. Week 9 and 10 is complete.
Done, huh? Okay, so as I mentioned, right? So this is something for week 11 and 12 we are going to discuss. So I told you there will in your question paper. See, don't consider this for other subject also. This is only for stats. So there is only one question from week 12, which is very basic. Okay, which is very basic questions we have kept. So that is, if you are done with the lectures, or if you are done with the, AQ, or most probably GA, then that is more than enough to apply, like solve, for like, attempt this question, you can basically say. Okay. Okay, so let's me start. So basically, in week 11 and 12, so major concept is called hypothesis testing. 1 minute. There is something, give me 1 minute. There is some lag in my writing device, I think. Just give me 2 minutes. Huh? Let me fix it, please. Yeah. Am I audible to all of you?
Yes,
Yes,
sir.
sir.
Okay. Yeah. Thanks. Okay. So basically, we will see. Okay. We are going to discuss the major topics related to, hypothesis testing. Oh, no, there is something happening with my writing device. Uh, is it manageable?
Yeah, we are not seeing any problem, sir.
Uh, no, it's
Sir,
a
we are not
very.
seeing problems, sir.
Oh, great. Thank you. So basically, what do you? Because I'm not able to write the word properly. Uh, Is it okay, right? Are you able to understand whatever I'm writing? I think there
Yeah,
is
yeah. Hypothesis. Yeah.
yeah, something is going on with my device. I don't know. Sorry. Yeah. So basically, what is the hypothesis as we discussed it? So hypothesis is what? It's just a claim, or you can say an assumption for something, which is let's say based on, we can say, basically known facts, but it's haven't proved, right? For example, let's say, so what is the hypothesis? What is the claim? Basically, suppose you can say, okay, if I replace the battery of my vehicle, then you can say it gives better mileage. Okay, so that this is what? This is something assumption for which is based on known fact, right? So this is a known fact, right? Something you can say, okay, you will change your battery of your vehicle, then it will give you the better mileage, but this is not proven, right? This is just a claim, correct? Another hypothesis you can make, okay, if I am study for 8 hours a day, then I can score good marks in my exam. Okay, so are you getting my point regarding the hypothesis, right? What do
Yeah.
you mean by the hypothesis? Even you can say, if I eat more, then I will gain more weight or something like that, basically. Okay, so this is hypothesis, just assumption for something, you can say, which is based on known facts, but it's not proved that it's just a claim, you can say. Okay, and what you will do, what is the key procedure for hypothesis testing? So basically, as with the, I can write hypothesis testing. Okay, so I'm just wanted to explain what is the hypothesis. In hypothesis testing, what we are doing. So this, in here, what we will do, whatever the test will be, we will be having. So test, compare the uh, sample results with, one second, this issue. Okay, so what is this? So what is the hypothesis testing procedure? So here, whatever the test is there, so that test compare the sample results with those that are expected when the null hypothesis is true, right? So that's what we are doing under hypothesis testing procedure. Are you getting me? So means you will assume your null hypothesis is true, and you will your test will compare these sample results. Is this okay? Are you getting? Basically, so suppose, let's say, I'm saying there is a coin. Okay, so first, what kind of hypothesis you can make? First of all, you will say, okay, this is unbiased coin. Okay, let's say alternative is it's a biased coin. All right, so what will be your procedure for this? Tell me, like, what will you do under hypothesis testing? So what hypothesis testing procedure you can say? So thing is, under hypothesis testing, you will collect some sample. Yes or no?
Yes, yes.
Yes,
Correct. So what you will do under hypothesis testing? Okay. So using samples. Okay. You are going to decide between what? Can you guess?
Whether sample coin is biased or unbiased.
Yeah, whether coin is biased or unbiased. Basically, you can say you are going to decide between null hypothesis and alternative
alternative
hypothesis.
hypothesis.
So, okay, okay, a rough picture is clear in your mind. What is the hypothesis testing,
Yes, sir.
right? So basically, under hypothesis testing, hypothesis means you are going to make a claim, and you will collect the sample for that claim, and based using those sample, you are going to reject or accept your null hypothesis. Okay.
So how do you decide which is H0 and which is HA?
See, it depends on the claim. I have some examples. Okay, we will see that one. Okay, so see, null hypothesis is something which you will say, let's say okay, suppose your coin is there, right? You want to check the coin, correct? I mean, whether coin is unbiased or not. So what should be your null hypothesis? So first of all, you will assume, yeah, coin is unbiased, right? For example, suppose you are a owner of a manufacturing company, okay, then you are manufacturing some product, okay. What kind of claim you can make? Yeah, you can make claim like your product
My
is of
products are quality. Yeah.
good quality,
Good
right?
quality. Yeah.
You are not going to make a claim like your product is of bad quality or not.
Correct.
Now at the same time, suppose there is one market researcher or market analyst or some data analyst. Suppose he suspect like your product is not of good quality. So alternative will be your product is of not of good quality. Now what he will do? He will collect sample from your company, some random sample. It will depend on the objective whether he's going to test the on an average performance or variability. It will depend. The thing is he will collect the sample and based on that sample he then at the end he will I mean based on the result he will decide whether your claim is true or your claim true or not. Okay.
Okay.
Ajay, what's your doubt?
Sir, so null hypothesis is something which is always true regarding that particular sample of data. Can we say it like that, sir?
Actually, see, null hypothesis is something you can say. True means what? I mean, what do you mean by what you are trying to say?
So true means like whatever the hypothesis that has been stated,
Hmm.
it is true. Like
So
it
no.
cannot be
You
false.
you you will assume you will perform your test by assuming this is true. Okay, and based on the result of the test, at the end you will make conclude whether that was true or not. Okay. So
Okay,
basically,
sir.
what you will do, I think we have discussed in week 12 open session. So what is under null hypothesis? You will going to make the statement like sample statistic does not differ significantly from the hypothetical value of parameter. So this is hypothetical value of the parameter is based on your claim, right? And what you will assume there is no significant difference. Okay, let's say what is the meaning of this statement? Suppose you are saying on an average this sample statistics, okay, the sample average, there is no significant difference between this sample average and this whatever the hypothetical value of mu. Okay, so this is the assumption, this is a claim. Okay, so I told you, right, what is the hypothesis? Hypothesis is just a assumption for something which is based on known facts but hasn't not it's haven't proved it. Okay, you have to check. All right, now, so based regarding this hypothesis testing, there are some basic steps we have to uh, think, right? So there is something called acceptance region or rejection region, right? So acceptance region is what? And rejection region. Okay, anyone can tell me what do you mean by acceptance region?
There is the
Region in
region where
which
you accept the null,
Okay, and what is the rejection region?
where you reject the null.
Okay, great. So suppose this is my normal distribution curve. Okay, it should be bell-shaped curve. So suppose this is z equal to 0. This is curve for standard normal distribution. Okay, suppose I'm saying this is C, critical value. Okay, so if what if the suppose you are going to perform for, let's say, on an average, if your value of test statistics will lie in this area, so this will be, and then you will reject, correct? So this is basically this is rejection region. Okay, and this is the alpha, correct? Alpha means probability of rejecting h naught when you are assuming this is h naught is true,
True.
and this will be 1 minus alpha. If alpha is rejection region, then this will be acceptance region.
Yeah.
Are you getting? Correct. So this
Yeah.
is for right tail test, means you might have some two kind of test, and then What about left tail test? So left tail test means, okay, this means right tail test means, suppose H naught you are saying, I'm taking the example of, let's say, biased coin. So you will say, okay, H naught will be P is zero point 0.5 for unbiased, okay, and alternative will be what?
P is more than 0.5.
P is more than 0.5. So this is your rejection region. Correct? Are you getting my point?
Okay.
So, okay. Similarly, if your let's say you are interested to check, okay, null is P is equal to zero point 0.5 and alternative is, let's say, P is less than 0.5. So this means at the end, okay, so just assume this my writing device is not working properly. Okay. So this is space
Sorry
temperature.
to
Okay.
sorry to interrupt you, sir.
Ah,
Actually, sir, I attended your Monday session in which you already discussed these concepts. You
hmm.
told only one important topic is left. Sir, which is this topic and what was that? Which will be that topic, sir?
No, no. So that topic was from week 12. I will come to that. Okay. Don't worry. I'm
Oh,
just
oh,
quickly covering. Okay. So
okay.
in left tail test, so this is your critical value. You will find this, and if your sample results is less than this C, you will reject. Okay. So this is called left tail test. And what do you mean by two tail test? So suppose
Not equal
null
to
Not
hypothesis.
equal to 0.5.
Correct. So this is P equal to zero point 0.5 and alternative is P is not equal to zero point 0.5. So this means your curve will be bell shaped curve. Okay. So just treat as a bell shaped curve. Okay. And this is 0 and there will be some C and there will be minus C. So you can treat this as a minus C. So this is rejection region and this is rejection region for two tail test, because in two tail test you don't know which side it will be. It will be here this side or it can lie this side also. So if the result is lying after this, you will reject. So this means this is the rejection region. Okay, so this will be alpha by 2. Yes or no? Overall, if you are taking alpha as a
Yes.
level of significance, so both will like, okay, if you combine it will be alpha. Okay, so this is the rough picture about your uh, this one side tailed like and two tailed test. Okay, so now what is the usual procedure actually we have to proceed? Yes, Pranav.
Yes, sir. Sir, I had a question. It's
Mhm.
for this one. Suppose
Uh-huh.
if they say that the company has a training program and then there was some initial average score for
Mhm.
the exam, and then after the program, the company claims that its program improves the score, करके.
Mhm.
And then they're asking to do a hypothesis testing against the company's claim. In this case, what is the null and what is the alternative?
Okay. No, no. Can you come up again?
The
Hmm.
company claims that initial score was 65 out of 100,
Hmm.
but average score,
Hmm.
and then after that the test was increased.
Ego. Wait.
Yeah. Good. Good.
Yeah, so it claims that the average score is increased after its thing, and then it gives a sample mean करके it's 68.
No, no. So that average score has been increased after sample observation or
After
yeah,
training program, and the
after.
claim is that our training program increases the score. That's the claim.
So thing is, it should be first of all defined
Those are
clearly written.
different populations, no? Before training and after training will be different populations.
Correct. So that's something can come under the two sample test, right? So you can say like maybe
Achha.
it's not covered in stats 2. That is called paired t test, if I'm not wrong. So under paired t tests, what is happening? Let's say you are saying there are. Let me give you one example. Suppose there are one drug. Okay. Let's say there are some 10. You collected a sample of, let's say, 10 animals, and what you are going to see the effect of drug before giving the drug and after the drug. Okay, I mean you are going to observe the, so this is something you are going to say, check the pair t test dependency something, and that is not covered in stats 2. I mean, I think that is under, maybe you can check uh, additional content, but usually we are not giving that one. Okay. Okay, I will come. We can discuss that one. Okay, let's.
Yeah.
Okay. So for the hypothesis testing procedure, there are two important things called size and power of test. Size, you can say level of significance. So what is the level of significance? Generally, we are denoting with this as a alpha. And what is this alpha? Alpha is all. It's nothing but probability of type 1 error. Okay, so most of the people, they are saying alpha is type 1 error. No, alpha is probability of type 1 error. And what is the, see, there are two kind of errors. So what is the type 1 error? So type 1 error includes you will reject your null hypothesis when H naught is true. Okay, so let me give you some example for this. Okay, so maybe hopefully that will give you a clear picture about this alpha and beta. So last time I gave you some example, but okay, let me give you some another example. Suppose I'm saying, okay, before this, let me explain the beta also, then you will see. Okay, second one is called beta. Beta is not a power of test. Beta is the probability of type 2 error. Okay, so what is the type 2 error? Anyone? You are going to accept signal when
alternative
is true. Correct. And what is the power of the test? So
1
by
minus beta.
1 minus
okay,
beta.
by the word can you recall power? Power means something good, right? So 1 minus beta, good means you have rejected that thing. Then
Alternate is
Alternative is 2.
okay, now let me give you one example. So last time I took one example. Probability that there is a one item. So item is of good quality. Okay, not like this. Reject think that item which is of good quality. Now what is this?
producer's risk.
That's okay. In terms of this alpha beta,
Alpha.
alpha, right? Because you have rejected that item even it was of good quality. Okay, suppose I'm saying accepting that product, then
Product is bad.
Bad quality.
bad quality. Okay,
Beta.
this is beta. Now if I'm saying I am rejecting a product, okay, when it is bad quality, correct?
Power.
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 Now this is
Power.
power, right?
Power.
Is it clear?
Yes, sir.
Now
Yes, sir.
let me take another example. Suppose I'm saying, you will tell me whether where I should include. Okay, suppose I'm saying probability of approving a drug that is not effective,
Beta.
Beta.
and rejecting a drug that is actually effective,
Alpha.
Alpha.
right? So are you able to relate now, right?
Yes, sir.
Now suppose I'm saying another some diagnosing a healthy person as a COVID positive, then
Sir, can you repeat the question?
okay,
That
let
is
me write.
alpha.
Let me write. So suppose probability that diagnosing a healthy person, just a thing, as COVID positive.
So alpha.
Beta.
Alpha, sir.
Beta.
Beta.
Just a thing, you are diagnosing a healthy person. That means you are
Since you are
rejecting.
rejecting that healthy person, so
Yeah,
Accepting
correct,
healthy
correct,
person.
right.
Even he is COVID positive.
Yeah, even if now let me write another thing. So, see, this is something I'm just giving, trying to explain this. Don't worry, this is going to come your interim exam. Just wanted to give you a flavor. Okay,
Sir,
so
the previous question, that is alpha, na?
yeah, you tell me. Just think.
Beta.
Convicting, let's say I'm saying convicting an innocent person. What it will be?
Beta.
Alpha. Beta.
Alpha, sir.
Okay, first of all, what will be your null hypothesis?
So null hypothesis will be innocent person.
Innocent person, right?
Yes, sir.
Okay.
And we are rejecting that.
You are rejecting that innocent person, correct?
Yes,
So this
sir.
is your alpha. Okay. And what is the beta? Accepting a null when H is true. So you are acquitting a guilty person. So H is that person is
Guilty
a
person.
guilty.
Guilty.
Correct? Now is this fine, right?
Okay.
Okay.
Yes, sir.
So this is the role of alpha and beta. If you'll do 1 minus beta, that will give you the power of the test. Okay. So one more thing, we have to keep alpha and beta as low as possible. We can do for our acceptance set. Okay. Yes.
Sir, what is the significance of power of the test, sir?
See, power of the test will give you. Okay. What is this? So this will give you something you can here think as a power. See, power is, if you think as a intuition, like in general. So power is nothing but it will it will give you the probability of rejecting H naught, and when H is true, right? Means suppose you have rejected a lot or a product when it was a bad quality, so that should be high. Okay. So if you are saying like this, so when this was true and you have rejected that lot, and when it was high, then you will say this is your power of the test.
Fine, sir.
Okay. Now, yeah, this
Sir,
is in general.
apart from this, sir, sir, may I know the weightage of the sum?
I think I have already posted on the discourse. Okay, and it would be great we can focus on the more discussion. Okay, we have already posted on the discourse. Please check from there. Okay. Okay, so for hypothesis testing, so let me do one thing in general. Okay, then we will proceed with the main question part. Okay. Okay, what should we do in general first of all? Okay, let me do one more thing. What is the p-value?
The minimum alpha value at which we will reject the null hypothesis.
Minimum alpha value, right? So basically, okay, sometimes maybe you have seen, yeah, go ahead. Yeah, someone is saying something? No? Okay, so p-value is nothing but it's the lowest significance level. Okay, at which we are rejecting the null hypothesis. Okay, so basically, suppose this is your graph, for example. Okay, and this is your mean. Okay, suppose this is your critical value, for example. And in case of alpha, what you will do? So this whole region comes under the alpha, right? If your x bar or value of test statistics will lie here, you will reject, correct? But what's the role of p value? Suppose this is some another value t dash, and p value is this region. Okay, so p value is the lowest significance when you are going to reject your null hypothesis. Okay, so if okay, suppose here there's any value of test statistic. Let's say this is t. Okay, this is and if my t is greater than c, this means what? I'm going to reject H naught at alpha, correct? If you ignore this C dash, if suppose T is here, then this means you are going to reject your null hypothesis at alpha, right? For example, suppose this is another C dash, okay, which is lowest significance, and your T is greater than C dash. That means I'm going to reject my null hypothesis as alpha now. Sorry, alpha dash. Are you getting my point? So this is your p value part. Okay, this highlighted one is the p value. P value is nothing but the lowest significance level. Okay. All right. Any doubt?
So lowest significance level at which you still
We are rejecting.
H naught.
Yes. So sometimes maybe you can see online or some other books. So if the
suppose you have calculated p value, right? If p value is greater than alpha, tell me whether you will reject or not. Alpha, suppose alpha is given as 0.05, okay, and p value is something you got. If p value is greater than alpha, then what you will do? You will reject or accept?
Reject.
So we'll
Accept.
Just think a
accept, sir.
bit. See, this is alpha. Alpha is 0.05. P value is greater than alpha. That means this will be somewhat here, right? Yes or no? Are you getting my point? So alpha is 0.05. We are getting p value that is greater than alpha. That means what? This comes under the acceptance, right? Yes or no?
No, sir, we're thinking 1 second.
See, okay, if you see this blue part, this is my alpha, right? After this is alpha, correct? So suppose you calculated the p value. P value is what? It should be lowest significance at which I'm going to reject my null hypothesis. But my p value is greater than alpha already. It's not lowest significance value of alpha, right? So my p value is comes under this region, this below before this blue line, correct? That means what? I'm going to accept, right?
Okay.
Okay. Now
That means
No,
p
sir.
value lies in the acceptance region.
Sir, 1 second.
Sir, I have a doubt, sir. Sir, so you're
Yes,
basically telling that, sir, so you're basically telling that p value is outside the null hypothesis, so we are accepting it.
See, 1 second. See, if you not like this. So, okay, let me try to explain it. Okay, what is the p value? P value is the yeah, go ahead.
So, sir, here I think at least the confusion that I am having is, see, there is one value C, critical value. There is one value P, and third is the sample value, right? Now, in order to reject or accept, it all depends on the sample value, right, sir?
Correct.
So if sample value is right side the C, okay, if sample value is right side the C, anyway I will be rejecting H naught, whether P or
Correct. So okay, let me add one more statement. So this is one of the procedure, you can say, based on which we can accept and reject also. Okay, if you are not getting, that's okay, but let me try to explain. So this is the usual procedure we will follow, right? If my test T is greater than C, we will reject. X bar is greater than C, less than C. That is something usual procedure we will see. But this is one of the also procedure you can find. If you are not getting, don't worry about your end term exam for this term. You can explore more on it. Let me explain one more time whether you are getting or not. So p value is what? Is the lowest value of alpha where I'm going to reject. That's fine. Okay. Suppose I'm saying alpha is 0.05, then I will reject only when this should be the case, right? If values are lying here, correct? Then I'm rejecting. Now p value is what? It's the lowest value of lowest value of alpha, right? So it should be less than 0.05 only, then I'm rejecting, right? See, if this part is whole part is 0.05. So this part, let me add another color. This red one, this will be less than 0.05, right?
Correct.
Yes.
Then I'm rejecting.
Okay.
What I'm saying, if p value, suppose you calculated p value by mistake, p value came 0.06. That means what? You are coming somewhat here, right?
Yes.
I will. No, so if the red line is coming there, which means I will be rejecting.
No. See, p value is the lowest value of 6 is alpha. Suppose I have fixed already, right? So I'm saying you have to test the whatever the hypothesis testing at 5% level of significance. This is level of significance I have given already. Okay. Okay. So if your value is lying here after this blue, you will reject.
Correct.
Now, okay, that usual procedure is clear, right? If that is there, you will reject or not, right? And p value is the what? P value is it should be lowest alpha, not more than alpha. Okay. If your p value is coming more than alpha, that means you are going to accept null hypothesis. Okay. If you're not getting, don't get confusion. Okay, I think I shouldn't discuss here. Actually, this is not in your here is course. I just wanted to add one more thing regarding p value. Okay, by the way, this idea is clear or not? Lowest significance alpha. Okay, that is okay. Lowest significance. Okay, if that is okay, just ignore this as of now. Okay, don't worry.
So
Alright.
I think lowest is because we are taking it with respect to mu. So I'm moving
Okay,
to the right side of mu.
okay.
So that's why we are saying that it is the lowest.
Let's ignore as of now. You can think a bit. Okay, just ignore as of now. Okay, let's discuss the usual procedure of testing. Okay, yeah. So let me discuss then, and then I will come to the question. So what is the general methodology of testing? Okay, so what is the general methodology of testing? I think this is something we are discussing long back. So suppose I have some sample which is from IID X. Okay, then what you will do? Okay, there is some background noise. Okay, then what we are doing? I am going to define a test statistic. Okay, let's say which is denoted as T. Okay, and what is this test statistic? This test statistic is nothing but some function of samples, right? Which can be
Yes, sir.
X bar, which can be sample variance or something like this. Okay. Now this is some function of sample statistics. For example, it can be X bar, sample variance, etc. Okay. Now what there are something acceptance and rejection region. Okay. So what will be your test? Tell me. If you have right tail test, then you will reject H naught if T is greater than some critical value C. This is when right tail test is there. Yes or no? And then you will reject H naught if T is less than minus some C. This comes under the left tail test. And you will reject your H naught if, what should I write?
Mod T is more than C.
Correct. Mod T is
Two-tailed.
greater than C. This is two-sided test. So this mod T is greater than C means your T is greater than C or T is less than minus C. So this is something we have seen here. This is here. You can say T is greater than C. You will reject. Here T is less than minus C. And in this part, mod T is greater than C. That means T is greater than C or T is less than minus C. In both cases, you will reject. Okay. So far, a rough idea is okay. Yes? No? Any doubt?
Yes, sir. Clear.
Right.
This T is less than minus C you're taking, like in notes, nowhere it is mentioned like minus C, nowhere it is taken. So I'm a little confused.
Okay, don't worry. It's just a critical value. Okay, for simplicity, you can go with C. Okay, don't worry. Okay, that's not a problem. This is just a critical. So I'm mentioning minus for left side tail, left tail test. Okay, that's not a problem. Okay. Now, so next thing is how to calculate this alpha and beta in some cases. Okay, so thing is, so this test statistics what? So if your null hypothesis, let me discuss from here. So this formula sheet will be given to all of you. Okay, so don't worry. So suppose your scenario is there something you have to test for mean. Test for mean means your null hypothesis is defined as a let's say my null hypothesis is defined as a, so there is test for mean. Suppose there are some sample as usual x1, x2, xn are IID from x. Suppose I'm saying my null hypothesis is I'm claiming my specific value of mu is some value mu naught. Okay, always remember null hypothesis will always be in terms of parameter value. Okay, and let's say I'm saying my alternative is mu is greater than some value mu naught. Okay, tell me what will be your test statistic? What will be your test first of all?
My test mostly will be the X bar.
Reject H naught when?
When T is greater than X bar.
X bar is greater than C.
X bar is greater than C. Sorry, yeah.
Right. So T is just X bar only, right? T is X bar only. T is the correct. Now, okay. So After this, first of all, how will you proceed? Okay, let me write for negative left hand. Okay, suppose null is mu is equal to mu naught, and alternative is saying mu is less than mu naught. Okay, then what will be your test? When you will reject, I am going to reject my h naught if x
If
bar
my
is
x bar is
less
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 than
than C.
right. Now, suppose I'm saying mu is equal to mu naught, alternative is mu is not equal to mu naught, then my test will be I am going to reject h naught if
Mod of x bar is greater than c.
mod of x bar minus e of x bar. Expected
X
value of
bar
x
minus mu, mod of
Mu
x bar minus mu.
greater than some c, right?
Greater than C.
Okay. Now, then as usual, what is the usual process? So suppose let me go with this. Okay. Suppose I'm saying my h naught is mu equal to mu naught. Okay. Alternative is saying I'm saying mu is greater than mu naught, and I'm saying I will reject my h naught when if x bar is greater than c. Then how to start? First of all, see, if alpha is given to you, okay, then the very first step, just start with alpha. Alpha is what? Probability that rejecting null
Rejecting
hypothesis
null, given that is
when
true.
null is true.
True.
Okay, then what you will do now? So alpha is, let's say, 0.05. Okay, then probability that rejecting, you will reject your null when x bar is greater than critical value, and h naught is, let's say, mu is equal to
You
mu
know.
naught. Okay, now what will be the next step? Let's go with
Convert to standard normal variable.
correct. So first of all, if x1, x2, xn are IID, okay, let's say this is from IID x with, let's say, mean mu and variance sigma square. What will be the distribution of x bar? It will be mu
Mod.
comma sigma square by n. If this is normal mu comma sigma square. Okay, so to convert into standard normal form, what we have to do? We have to subtract the mean. Okay, that means x bar minus expectation of x bar divide by standard deviation of x bar.
Yes.
Okay, and which is
Root
greater
n.
than c minus expectation of x bar divided by standard deviation of x bar, given that mu is equal to mu naught. All right, so this will be what? So this will be now z greater than c minus mu divided by square root of sigma square by n, given that mu is equal to mu naught. So the value of mu you can find from here. So this will be probability that z greater than c minus mu naught divided by sigma by root n. Correct. Now the next step is we have to convert into abject form, right? That is
one
CDF of.
minus.
So what
1
I will do
minus
is,
LZ.
yeah, correct. So I will do
1.
1 minus probability z lesser equal to c minus mu naught divided by sigma by root n, and then the usual procedure, right? So it will be probability z lesser equal to c minus mu naught sigma by root n equal to 1 minus alpha, and alpha you can put, it will be given whether it's a 10% or 5%. So it will be abjad of c minus mu naught divided by sigma by root n equal to 1 minus alpha, and then from here you can get c minus mu naught divided by sigma by root n equal to fg inverse of 1 minus alpha, and this value will be given to you, right? And from here you can calculate the value of c as a mu naught plus sigma by root n fg inverse of 1 minus alpha. Just substitute all those values, and then you will find the value of c. Then at the end you will compare, since it's a right tail test, you will see whether x bar is greater than c, then you will reject, yes or no, and if it's less than c, you will accept your null hypothesis. Correct. So rough idea is okay to all of you. Okay, suppose there is two tail test. Okay, then you will proceed with modulus of x bar minus mu greater than c. Okay, don't worry about how to proceed. Okay, these all things are given to you. Okay, these all things will be given to you. So the main thing is you have to apply. Okay,
It
so
will be
okay.
available in exam.
Yes, it will be available in your exam. Okay, so this part, okay, in this case, when you have two tail test, modulus of x bar minus mu naught greater than c, to convert into standard normal variable, what you will do?
Just divide by the
Correct.
standard
Just
deviation.
divide by standard deviation, because mu naught is already subtracted. So what people generally made mistake, they again divided c. They are again subtracting c minus mu naught. Okay. Try to avoid here because already mu naught is there. Okay. The thing is you have to do, you have to basically divide by sigma by root 10. Here sigma by root 10. It will be now left hand side will be modulus of g greater than c divided by sigma by root 10. Is this clear?
Yes.
Yes.
Okay. Okay. So rough idea is okay to all of you till now. What is the usual procedure, alpha, beta, and all? Clear? Yes.
Yes.
No.
Yes,
Okay.
sir.
If that is okay, everyone has pen and paper.
Yes.
Okay. Let's
Yes,
try.
sir. Yes, sir.
Let's try to apply the concept. Okay. So this is one question. It was already asked in one of the previous term. Okay. This is, I think, very simple. So MGF of random variable is given to you. Find the value of this. Okay, first of all, tell me one more thing. What kind of MGF is this? I mean, of which random variable? Can you recall?
Poisson's distribution, sir.
No, no. Do not say anything randomly.
Normal.
Normal. See, if you can see the lecture,
E power lambda square sigma square by 2, some that form.
yeah. So if x follows normal 0 comma sigma square, right? Then mx lambda will be e raised power lambda square. It's a e raised power lambda square sigma square by 2. Now you can relate with this. Okay, so what you can make it? I can make it e raised power 4
Sigma square will be
lambda
4
square.
lambda square by 2.
Can I do this one?
Yes, sir.
Now what is sigma square now?
4.
What is the mean?
4.
Mean is what?
0.
0.
0.
0, right? Now to convert into in this form, we know probability that if a see, then what I have to do to convert in FZ form? I have to subtract the mean. So it will be minus 4. There is some lag in my writing device. I'm not sure what is happening. So this is something I can write minus 4. Okay. Minus 0 divided by 2. Yes or no?
Yes, sir.
Less than x minus 0 divided by 2.
Yes, sir.
Less than 4 minus 0 divided by 2.
Yes, sir.
Everyone is getting my point, right?
Yes.
So
Yes,
from
sir.
here, we had to just identify what is the mean, what is the and don't worry, this will be given to you. Okay. So probability that it will be minus 2 less than this, I can write as a z, and this I can write as a 2. Is this clear? And we know probability that a less than x less than b. What I can write?
FZ
F of
B
B minus.
minus
Correct.
FZ
Fz of b minus fz of a.
A.
So now what it will be fz of 2 minus fz of minus 2, which is c. So you can see this is 3-mark question. It will take 1 or 2 minutes. That's all.
Sir,
Clear?
can you go a little up, sir?
Yeah. Okay. Fine.
Little up. Okay. E to the power of lambda square. Sigma square.
Sir, can you explain this e power 4 lambda square by 2 step again, sir?
See, it's given e raised power 2 lambda square, right? It is given to us. But we know the form of MGF of normal distribution. It's e raised power lambda square sigma square by 2 when x is normal 0 comma sigma square. Correct? The 2 which is given to us in the power of e, that 2 I can write e raised power 4 sigma square by 4 times lambda square by 2.
Sir, so we are multiplying and dividing by 2.
No, we are not multiplying dividing by 2. You can say, yeah, that's also one of the way to look at it. But what I'm trying to say, I want to just convert in this form. Okay, so you can say you are multiplying and divide by 2, or else I can say this 2 I can write as a 4 by 2. Anything is fine. Correct? Yeah,
Yes,
that's
sir.
clear. Any doubt in this question?
So this will be also twice fz2 minus 1, correct?
Yeah, that's another approach. You can convert this part as a greater than like basically what
Correct.
else you can write? You can write this as a probability z less or equal to 2, right? And this part you will write probability z is less than or equal to
1
minus.
minus. Yes.
And we know from the standard normal curve, if this is a, this is minus a. So by the symmetricity concept, this is same as this one, right? Basically,
Yes.
probability z less than minus a. This is same as probability z greater than a.
Yes.
Are you getting here? There is
Yes, yes. It is symmetric. So
Yes, sir.
then
Yes,
there
sir.
will be same.
There is issue with my writing device. I don't know what is
No,
happening.
no, this is coming perfect here.
Okay, let me rewrite this one. Okay, so this is something if you see, so can I write this a probability z less or equal to 2 minus probability z less or equal to minus 2? Correct? So by
Yes, sir.
normal curve, standard normal curve, we know this, that is the bell-shaped symmetric curve. So suppose this is 2 and this is minus 2. So if probability z less or equal to minus 2 will be same as probability z greater than equal to 2.
Correct.
So this part, can I write probability z less or equal to 2 minus probability z greater or equal to 2? Correct? Now, if this is the okay, so can I write this part as a 1 minus probability z less or equal to 2? Even you can write this as a directly. Yes or no? Now probability z less or equal to 2 minus 1 plus 2 probability z less or equal to 2. Sorry, 1. So this will be total 2 times probability z less or equal to 2 minus 1. Yes or no? And same way you can go with this also. You can convert 1 minus probability z greater than 2, and this z greater than 2 will be again probability z less or equal to 2, and it will be 1 minus something. Clear? The key thing you have to observe, probability z less or equal to minus a, this is same as probability z greater or equal to a. Suppose this is a and this is minus a. So this is going to help you whenever you have mod of t greater than c, or mod of x bar minus mu greater than c. Yes or no? Because in this case, you will get mod of z greater than c divided by sigma by root n. Yes or no? Are you getting my point?
Yeah.
Okay, so this, let's say I'm going like this. Suppose this is the case. So what you can write? You can write probability z greater than c by sigma by root n, or
Plus.
yeah, plus probability z less than minus c by sigma root n. Correct? Now you can whatever the value will be there, you can convert this in greater than form, or whatever the, I mean, it will depend on the option, whether your option is given this as a positive values, in terms of positive values, or in terms of negative values. Okay, if it is given in terms of negative value, just convert this positive using this concept in negative values. If this is given is a positive value, convert this in the positive one. Clear? Yes, no?
Yes, sir.
Okay, let's try
Yes,
to solve this question. This kind of question is important. Okay, this is helpful for you. So question is, consider 100 samples x1, x2, x100, IID normal mu comma 36, and your null alternative is given as mu equal to 4, and alternative is given as mu is equal to minus 4. Okay, question is there is a one t which is test statistic, which is I mean x bar only, but it's given as a t, and you are going to reject that test when t is less than c. Okay, it's a given, test is already given to us. You are going to reject test when t is less than c for some constant c. What is the level of significance in terms of c? So level of significance is what? Alpha. Alpha is what? Probability of
Rejecting
rejecting
H
null
naught.
when
H
h
naught is
naught is
true.
true. And alpha, what is the probability of reject when you will reject your h naught? When t is less than c.
Given.
Yeah, it's a given, right?
Mu
I'm going to
equals
reject h naught. And what is h naught?
Mu is
Uh,
equal
mu
to 4.
equals to
Mu is
4.
equals to 4.
Correct. Now, what? Okay, tell me. I told you right. If x1, x2, x100 are normal mu comma 36, so what will be the distribution of t here, which is x bar? It will be normal
Normal.
mu comma sigma square by n.
Yes.
Okay. So this is something you have to keep in your mind. Okay. This basic thing will not be given to you. Okay. So now what I have to do? I have to convert in standard normal form. That is t minus expectation of t divided by standard deviation of t, which is less than c minus expectation of t divided by standard deviation of t. So far so good.
Hmm.
Any doubt?
No.
So it's given that t is equal to x bar is follows normal mu comma sigma square by n, right? So mu is unknown to us, right? So this is test for mean. You can see test for mean means here mu is unknown and we are making hypothesis for mean and we are going to test. Now, so sigma square is what? It's a 36 and sigma n is 100, right?
100.
So alpha will be probability of, so this is, I can write directly as a z
Hmm.
less than c minus what is the expectation of t mu
4.
divided by uh, square root of 36 divided by 100,
100.
given that mu is what? This is 4. So alpha will be here z less than c minus 4, because I can substitute the value. It will be 6 by 10.
6 by 10.
0.6.
Yeah, 0.6, or else if you see the options are in terms of 2 and 3. So what else I can write? So this is I can write 3
3 by
by
5.
5, right? So alpha will be probability z less than 5 by 3 c minus 4.
Yes.
Correct. So alpha will be fz of 5 by 3 into c minus 4. Okay.
Second option.
Yeah. No.
Sorry, fourth
D. Okay. So actually, if you will solve this, it will be fz of
5c minus
5c
20.
minus 20 divided by 3, which is D option. You can see. Okay. Okay. So here you can see there is no need to do 1 minus, because it's already in less than sign, and we know fz is what? Probability that z less or equal to some value. Okay. So it should be less than or equal to form to convert into z. Fz. So suppose your test is t is greater than c, then you have to do 1 minus. Yes or no? Correct?
Yeah.
Okay. Now it's fine, right? Are you able to relate?
Yes.
Now come to the next question, but I want you to try this question. See, don't tell me the direct answer. Answer is given to you, but take your time and let me know. Okay, because this is something which it will test your knowledge. Okay, I'm giving you 2 minutes. Okay, then I will discuss.
Sir, done.
Done, sir.
Sir, done.
Hello. So is this done? Are you getting the answer or?
Yes, sir.
Yeah.
Okay. So should I do quickly?
Quickly do it, please.
Okay. So what is the one minus? Sorry, power of the test. It's a
1 minus beta.
1 minus
which
beta.
is probability of
Rejecting H naught.
Rejecting H naught.
H
Okay.
is true. H is true.
H is true. So you can see, I think this is given to us. Maybe it will be. No, it's not there. Okay. So now if you see, so that's why it's given, some value is given. So 1 minus beta, when you will reject, it's given that t is less than c, and when mu is minus 1.
Minus 1.
Okay. So see, you can see for mu is equal to plus 1 is answer is given to you. Okay. So sometimes
Yes, sir.
people by mistake they take and they felt, okay, it's in option. Oh, I'm right. I'm correct. Okay. So please be careful of these minor things. Otherwise, question paper will be very easy. Now, so what is, now tell me what will the x bar here? Distribution of x bar. I mean t. It's a normal mu comma sigma square 16 divided by
100.
100. So it will be t minus expectation of t divided by standard deviation of t less than c minus mu. I'm writing directly square root of 16 divided by 100.
Yes,
And
sir.
mu is minus 1.
Minus 1.
So it will be probability g less than mu minus 1 value of
Yes, sir.
minus mu, and it will be
Yes,
4
sir.
by 10.
4 by
10.
4 by 10 is will be what?
5 by
2
2.
by 5.
2 by 5, I mean.
Yeah. So
2 by
2
5,
by
sir.
5. So now it will be probability j less than 5 by 2
5 by 2 into C plus 1.
c plus 1. Sorry, not fourth is correct. Fifth is sorry.
Second is
Second is
correct.
correct. Fourth is wrong. So fourth will be correct when you will take mu as a plus 1. Okay.
Yes,
Then
sir.
it will become c minus 1. So it will be fg of 5c plus 5 divided by 2. Okay.
Yes.
We can see as a second option. Is this clear? So this, you can say this kind of questions we can ask. Now, what about this? I think I'm not going to solve this question, but there will be a twist, right? So what is the change here? It's a probability that reject H naught. Okay. So power of the
Sir,
test.
1 minus.
Yeah. So this is rejecting H naught when HA is true. So this will be T greater than C given that mu is equal to what? 3. Now, what will the distribution here? Distribution of T will be normal mu comma 9 by 100. Right. So now it will be probability T minus expectation of T divided by standard deviation of T greater than C minus expectation of T divided by standard deviation of T given that mu is 3, HA is true. So HA is, that means mu is equal to 3 we have to take. So this will be G greater than C minus mu divided by square root of 9 by 100 given that mu is equal to 3. Yes or no? Then probability G greater than C minus 3 divided by 3 by 10. Since we have to convert in form of Fz, so what I have to do is greater than. I will write 1 minus probability Fz, probability that Z less or equal to C minus 3. It will be basically 10 by 3, right? And I can write 1 minus Fz of 10 by 3 C minus 3. Correct? So you can see B option is correct. All right? Any doubt? Is clear, right?
Yes.
Okay, now let's come to this question. So this kind of questions is, I will say again, it's a very, very, very important. Okay, this kind of question will be similar questions will be there. So question is, a university claims that the average time for a student to complete a particular exam is 60 minutes with a standard deviation of 5 minutes. Okay, here you can see it's given that x1, x2, xn with the normal. Okay, standard deviation is given to you. If standard deviation is not given to you, then you will go for t test, right? Yes or
Yes,
no?
sir.
So Then an analyst believes that the average time is less than 60 minutes. He randomly selects 100 completed exams and finds that the average completion time is 59.3 minutes. So this is your N. And what is
Yes,
this?
sir.
59.3. This is,
H naught.
and this is your mu, right?
Yes, sir.
Now tell me what is the null and alternative hypothesis should analyst consider?
Null is mu equal to 60 and alternative is mu is less than 60.
Why
B
not?
option.
Why not C? What's the wrong with C?
Because the analyst believes that it is less than 60. So that is our alternative
Okay,
hypothesis.
suppose I'm not mentioning 60. I'm just saying analyst believes that the average time is lesser. Suppose I'm saying this is a lesser, then
Our initial mu was 60, the null hypothesis one.
anyone, any thought?
Sir, if it is less, sir, initially what value they have given, if they are telling
60.
if it is lesser, then it should be in any case it should be lesser than 60 only.
No, actually, one more thing. Yeah, that's correct. But the one more thing, the null hypothesis and alternative hypothesis will always be for population parameter, not for sample. Okay, because you are making
Okay, sir.
claim for population. This sample values you are you have collected sample and you are doing your analysis, you are doing your study, and based on sample value, you are going to accept or reject this claim regarding the population, not for sample. Okay, so B option is correct. Okay, so B is correct. Now next question is, which of the following conclusions will the analyst reach at the specified significance? Suppose alpha is 5% and alpha is 1%. So whether he will accept or reject. Okay, so let me do it. Okay, so anyway, C and D is correct, but let's try to solve it. Okay, so first of all, what are the given? So if since we are dealing with, okay, what will be your test actually? Tell me. If null alternative hypothesis is this, what will be your test?
Z test.
Z test.
No, Z test is there. I mean, test means when you will reject your if X bar is less than some C. Correct.
Yes, sir.
Now X bar is 59.3. We have to find the value of C, whether we have to check whether it's correct or not, right? So thing is, how will we start? We will start with alpha. Alpha is probability that reject H naught when H naught is true. Alpha is, let's go with in general, and at the end we will put the value, okay, because we have to substitute two values. So when I will reject when X bar is less than C, given that H naught mu is equal to 60, right? Now tell me, what will the distribution of X bar? What will be the mean of X bar here?
Mean of the X bar will remain 60 only.
And variance of X bar?
Variance
Sigma
of X
square
bar
by
is,
N.
yeah.
5
What is
by
the, not 5, it's the standard deviation.
Yes,
Pi square by
25 by 100.
square by 100.
25 divided by
100.
100.
100.
Is this clear, right?
Yes.
Now, so next step, it will be X bar minus expectation of X bar divided by standard deviation of X bar. This will be less than C minus expectation of X bar divided by standard deviation of X bar, given that mu is 60. So if I will write probability, it will be G less than C minus 60 divided by 5 by 10.
5 by 10.
So this I can write as FZ of C minus 60 divided by 1 by 2.
Yes.
Yes, sir.
Or else you can say 2C minus
2C minus
2C
120.
minus 120.
So I will write 2C minus 120, right? So from here, what it will be, I can write 2C minus 120. Let me write all the steps actually. So can I write that 2C minus 120 same as FG inverse of alpha?
Alpha.
So basically from here it will be 2C equal to 120 plus FG inverse of alpha. So
Yes.
C will be what? 1 by 2
60.
120 plus FG inverse of 1 by FG inverse of alpha. Now alpha we have to test for two values, right? Two different. I mean for 5% and for
1%.
1%. So let's say when alpha is 0.05. So C will be 1 by 2 120 plus FG inverse of 0.05. So what is the value of 0.05? I think it's
minus
minus
1.64.
1.645. Don't worry, values will be given to you.
Yes.
FG of minus 1.645 is 0.05. So you have to substitute the value. Anyone can calculate the values and tell me the answer.
59.18, sir.
Overall?
C is 59.18.
Okay. Now what about alpha equal to 0.01? So this will be C equal to half 120 plus FZ inverse of 0.01. So I think for this, I can't recall the values. I think minus 2.32, if I'm not wrong. You can cross check. So actually FZ of minus 2.32 is 0.01. So FG inverse of 0.01 will be minus 2.32 or not, right? So anyone can calculate this one and tell me the answer?
From where get 0.01?
FZ of minus 2.32 is 0.01.
We will be given that value, but sir remembered that value and he is putting it there. That's it.
Yeah. If you are asking this
Okay.
0.01, so this is in option. You have to check for two values. Okay.
Okay, sir.
Yeah.
58.83.
58.83. So you can see then when I will reject if my X bar is less than C. X bar is what? 59.3, right?
59.3.
Correct. So if you see X bar is 59.3, which is less
It is
than.
greater than.
Sorry, which is
greater than
greater
C.
than in both cases, right?
Both cases, yes.
Right. So that means what?
We'll accept H naught.
So I will accept the null hypothesis at
In both the
5% and 1%.
1%.
One more thing you can basically think. Okay, I will leave on you. If this is 5%, if this is 1%, that means what?
P value is
So
1.
then always it is the case if 5% is there, then 1% will also be there.
No, just think it will change.
If
Okay?
you accept that
1% is there, then 5%.
1% you anyway will accept.
Okay. Just think. Don't think always it will be true, but just the thing. Okay, let me.
No, if we are accepting with at a significance level of 5%, we will naturally accept at a significance level of 1%. I think that is the interpretation.
Will it be always true? Can you think?
Yeah,
In the
if we are accepting at a significance level of 5%, that means it is below, it is left side of 5%. Correct. So then it will naturally be on the left side of 1% also. Unless
accepting 1%, then automatically accepting 5% will be true.
Correct. You are telling in
Opposite way, yeah.
See, if I'm accepting at 1%, that means I'm covering this whole part, right?
Correct.
That means it automatically covers the 5%. Okay. But in case of rejection, will it be true always?
Then it will be opposite.
It will
That
be reverse.
5% will be more than 1%.
Then it will be reverse.
Reverse, right?
Yeah.
Yeah.
Okay, yes, Ajay. Any doubt?
If I am rejecting
sir,
at 5%,
I have a doubt, sir.
I will be rejecting at 1% also.
Yes, Ajay. Go ahead.
Sir, so in this case, sir, anything which is between the region of 1% and 5%, we may accept or we may reject according to the situation.
Correct.
That depends on the. Okay, what about this? Okay, let's come to the next part. Okay. Yeah, that's correct. Just think about it. I think as for the time I'm moving. So suppose a principal states that the student studying in her school have an average IQ score equal to 98.5, right? A reporter suspects that the average may be higher and took a sample of 100 sample students from that school and found out the average IQ score is 98.78, right? Assume IQ score of the students are normally distributed with a standard deviation of 1.6. So you can see here, standard deviation is given to you, right? So that means I'm going to use the normal test, right? Z test. Okay. Now, which should be the correct option? B, A, C, D.
Sir, B.
B.
B, right?
B.
You got the full marks. Okay. So this kind of question I told you, right? Very, you will find for sure this kind of questions because we said the question. Okay. So this is kind of important question. So B is the correct. Now next question is you have to calculate the P value. Okay. Anyone can tell me how will you proceed for P value?
Sir, it is the lowest value of alpha.
So probability that rejecting H0 when H0 is true. So when is the lowest value of sigma? Basically, when you will reject here. What should I write for rejecting P values? Tell me. Just
We'll
think a
have
bit.
CST.
Sir, T is greater than C.
No, substitute the sample value. Substitute the sample value in place of C.
C, because that's what we are. C is what? C is the critical value, right?
Correct.
Okay. So we will assume that is the lowest, and we'll proceed with this. So
Correct.
T should be greater than 98.
C.
98.5.
7. So no, 98.5 is value of parameter, right? It's the value of mu, not for x bar. And when this is 98.5. So what you have to do basically, next as usual procedure, you have to convert in standard normal form. So T minus expectation of T divided by standard deviation of T. And what you have to do, 98.78 minus expectation of T divided by standard deviation of T. Given that mu is equal to 98.5. Tell me, Z greater than 98.78 minus, I can write mu, which is 98. What about standard deviation of T? Square root of what? What will the variance of T?
Mu upon n.
Sigma square by n, sir.
98.5, not 98.
No. The sigma is given 1.6.
Correct.
So 2.56 by.
Yeah, in the question, it's standard deviation is 1.6, right? So it will be 1.6 square divided by 100. Right? Now, next thing I will do probability. I will convert in 1 minus probability Z less or equal to 98.78 minus 98.5 divided by 1.6 divided by 10. Okay.
Yes.
Are you getting my point?
Yes, sir.
Okay. So next you have to just solve this and you will get FG of some value, and this value will be given to you and the answer will be 0.04. Okay.
Yes, sir.
Okay.
Yes, sir.
I'm not doing the mathematics from here. Okay.
So
Now,
first question, please repeat.
first question. This one.
Yes, sir.
Yeah. What is your doubt?
Why alternative hypothesis greater than 98.5?
Okay. So what it should be? I mean, what's your thought on this?
It may be not equal to no.
No. Can you read the question again?
Suppose principal states that the students studying in our school have average IQ score equal to 98.5.
Yeah, this is the session of stats 2. You can ask the doubt from stats 2, but at the end we can discuss. Yeah. Go ahead. Yeah.
Reporter suspects that the average may be higher and took a sample of hundreds random students from the school and found that average IQ score of those children is 98.78. Assume IQ score of the students are normally distributed with standard deviation 1.6. We take samples 100 random students from the school and got that average IQ score is 98.78. So how we form that hypothesis? Null hypothesis is okay. That it is given.
Can you read this question? This line, please.
Suspects.
Yeah, that's what he is going to check, right?
Maybe higher. Okay,
Yeah,
okay.
the same thing we did here, right? In the previous question, the analyst believes that the average IQ score is less than 60 minutes. So alternative is less than 60 minutes. All right.
Okay.
Right? Yeah. So the next topic. Okay, so this question is also important. So important means you can see this question we have already asked in some previous term. So you can see that this is very conceptual question, right? So it's a very concept based. Even if you don't know, you can simply go to the formula file and you can see when is this. So here if you see the question, right? So question is what? Consider the following situation, match it with the suitable test statistic and hypothesis test. What is the scenario? Suppose we observe samples from a normal distribution where variance is unknown. We want to check whether the mean is greater than mu or not. Then what test statistic and test can be applied? So you can see, first of all, this will be either A, C or D, right? For sample mean. But we know since we can't use chi-square because chi-square is we are using for variance. So this option is wrong. Now we have to check for t-test and z-test. So we can't use z-test because this is z-test is
That
used
is we
when
use it when we have the variance given.
known, right? You can check from here also. So you can see this is it will be given in question paper, right? So you can see it's a very, if you don't know, also you can check from QP. Sorry, this formula sheet, right? You can see test for mean, okay, when variance is known, z test, when variance is unknown, t test, right? You will get 3 into 2.5 and out of 100 it will be 7.5 mark. Okay, this the option D is correct. Is this clear? Okay, so let me explain you. So if it's given that x1, x2, xn are IID from x, let's say, which is and x is from normal mu comma sigma square. Okay, if sigma square is known, it's already given, and I'm going to test for mean. Mean means suppose my null hypothesis defined as mu equal to mu naught. Alternative is, let's say I'm saying mu is greater mu naught. I'm just taking one of the example. Then I will go for
Z
Z
test.
test. That means I will do x bar minus mu divided by sigma by root 10, right? To convert in Z form. Yes or no?
Yes.
Now, in case, suppose, just change the scenario. Suppose it's normal mu comma sigma square and sigma square is unknown. We don't know the sigma square. It's unknown to us. Then I will go for t test. And in t test, what we have to do? It's x bar minus mu. Instead of population standard deviation, we will
Sample variance.
Sample variance, and this will call as a t distribution with n-1 degree of freedom. Don't worry about degree of freedom. If you want to explore more, we have discussed in open session. As of now, let's proceed with this. So in case of jet test, we have seen, right, what we were doing. We subtracting the mean and divide by standard deviation, this sigma by root 10, right? And that would become normal. In case of t test, what it will be? Okay, so let me write. So suppose I'm going with this. I'm going with this mu is greater than mu naught. Okay, I'm just taking one scenario. Let me write here. Suppose I'm saying x1, x2, xn. This is IID normal mu comma sigma square, and this is unknown. Okay, this is not known to us. And then suppose my test is something like that. Okay, suppose I'm my null hypothesis. Before test, let's define null hypothesis. Mu is equal to mu naught, and let's say for now, let's say mu is greater than mu naught. Okay, now what will be your test? Now I'm going to reject my h naught if my test statistic is greater than c, right? This t will be x bar because we are dealing with mu, right? So you can see this is test for mean. That's why my hypothesis is about mean. Now, tell me one more thing. How will you proceed now? I mean, what is the usual procedure for to test your h naught? Alpha, right? We are starting with alpha. Yes or no?
Yes.
So I will reject h naught when my null hypothesis is true.
True.
And when you will reject, your t is greater than c and null hypothesis, let's say this is mu equal to mu naught. Since we are dealing with when variance is unknown and we know, I will go with x bar minus mu divided by s by root n. This will follow t n minus 1, where s is what? 1 upon n minus 1 summation I to n xi minus x bar whole square. So this is sample variance. So what we have to do, basically probability that t minus expectation of t divide by, or else let me do directly. Okay. So t is what? This is x bar, right? Because this will be x bar. Yes or no? And this will be t minus mu. I will write s by root n greater than c minus mu divided by s by root n. Would you agree with me?
Yes, sir.
Yes.
Now what should I write next? So if mu is equal to mu naught, I will write t minus mu naught s by root n greater than c minus mu naught divided by s by root n, because mu is mu naught. Can I write what should I write? This initially we were writing this as a
You can
z.
write t n minus 1.
Correct. T n minus 1 greater than c minus mu naught divided by s by root n. Since we have to convert always in CDF form, I would write 1 minus probability t n minus 1 less or equal to c minus mu naught s by root n. Yes or no? Now this will be probability t n minus 1 less or equal to c minus mu naught s by root n equal to 1 minus alpha. Can I write this as a f t and so this is just treat as a notation, right? Initially we were writing as a z. So this will be c minus mu naught s by root n equal to 1 minus alpha. From here I can write c minus mu naught s by root n equal to f t n minus 1 inverse 1 minus alpha, and c equal to mu naught plus s by root n f t n minus 1 inverse 1 minus alpha. The same like usually we are giving the value of like this, right? So we are giving fg of minus 1.645 is what? 0.05, right? So this will be fg inverse of 0.05 will be minus 1.645, right? So similarly, value of t will be given to you. Means it will be given as, let's say you collected 16 sample. So it will be ft15, let's say minus 1.645. Let's say you have some 100 sample, for example. Then t99, it's a 0.05. Then ft99 inverse of 0.05 will be minus 1.645. Is this clear?
Yes, sir.
Yes or no? So this is actually this is true. Why? If we have seen when sample size is large, all the distribution is going to approximate as a normal distribution, right? So if sample size is large, right? So this value, this normal FZ value is close to this T value. So that's not a problem. Yes, Prakash.
Sir, table value is for up to 29 only. How we write the T99? Is it from that value?
This is it will be given to you. Yes, yes. Actually, when n is large, right?
Yeah.
And T distribution is used for small sample. So in statistics, small sample, some books use less than 30, some books use less than 50. But don't worry. So if I mean, usually they took 30 as a standard size. If it's greater than 30, they consider as a large sample size. But that's not a part. So this will be given to you. See, I wrote here, right? This T99 is same as this one, right?
Yeah.
Why? Because you know the central limit theorem, right? Central limit theorem is says all the distribution when sample size is large is close to approximate to normal distribution, right? But anyway, don't worry, values will be given to you. Okay, this standard procedure is clear to all of you. You have to substitute this value, you have to find the value of C, and based on the test, you will reject or accept. Yes or no?
Yes, sir.
All right, this is clear. Okay. Yes, no, are you getting right? If you
Yes, sir.
Okay.
Yes.
Let me. So this was for test for mean. What about variance? If you want to test for variance, so there is something called chi-square test for variance. So as usual, we have seen the test statistics, right? X for Z test, T test. So there is one test statistics. If I'm writing n minus 1 s square divided by sigma square is follows chi-square with n minus 1. Okay. We will discuss about it. We can discuss it later, but this is your test statistic. Let's focus. So this is your T. Okay. Now, what is the procedure? Suppose I'm saying x1, x2, xn. are IID normal mu comma sigma square, right? Suppose I'm interested to check for the variance, okay? Then initially we were interested in mean only, right? So for mean there are two tests, T test and G test. Now what? So here what is the S square? S square is nothing but sample variance 1 upon n minus 1 summation I to n xi minus x bar whole square. Now when I will reject my test, tell me by saying this, I will reject my H naught if
When
greater than C.
right. In case of mean, what we were doing, x bar is greater than C. Here it's a standard deviation. So S is sample standard deviation. I will say this is greater than. You can write like this: sigma square equal to sigma naught square. Then you will say S square is greater than C square. Anything is fine. Okay, that's not a problem. Now, so what is the usual procedure? Now I will start again with alpha. Alpha is probability of rejecting H naught when H naught is true. And what when I will reject here H naught, S is greater than C, and H naught is what? Sigma is equal to sigma naught. So what is the test statistic? I have to convert in the form of n minus 1 S square divided by sigma square. It will follow F chi square n minus 1. Correct? So you can see this is S square. So can I write this as a S square is greater than C square? Would you agree with me?
Yes, sir.
Yeah.
Now, initially to convert in GA test, we were following that form. Here, what I will do, I have to multiply it with n minus 1. Yes or no? And divide by sigma square. Correct?
Yes.
Now, this will be chi square n minus 1. This term greater than n minus 1 C square. And this, since this is sigma naught, so I can write here sigma naught square basically, right?
Yes, sir.
So this will be alpha. Now can I write 1 minus probability chi square n minus 1 less than or equal to n minus 1 times C square sigma naught? Why I'm writing like this? To convert in CDF form, right? So what? It will be F chi square n minus 1 C square divided by sigma naught square. Correct? Are you getting my point? So this F chi square n minus 1 C square sigma naught square will be 1 minus alpha.
Alpha.
So from here, what value you can find? I can write F chi square n minus 1 inverse 1 minus alpha. Don't worry about these values again. It will be given to you if there is question. So C square will be what? Sigma naught square divided by n minus 1 F chi square n minus 1 minus alpha. Everyone is getting this part? So
Yes,
from
yes.
here, I will get value of C square, and when I will reject, if my value of sample variance is greater than C square, I will reject, otherwise I will accept. Is this clear?
Okay, sir.
Yes, sir.
Right? Now these all things is given to you again. I will tell you. So this is, you can see chi square test for variance. So this is given to you when you have to reject. Similarly you can go for left tail test, two tail test, right? Now we will see two samples Z test for mean. Okay, because we have seen one sample test, right, for Z. What if you have two sample test? Okay, so I will quickly go through that. So two samples, what is the heading? Two sample Z test for me. Okay, so now how will we proceed? So first of all, let's say I'm saying x1, x2, xn. This is IID. This is first sample from normal distribution, let's say with mean mu1 and variance sigma square. And another sample, let's say y1, y2, yn2. So suppose sample size is n1 here and here n2 in the second sample. I'm saying this is mu2 and sigma 2 square. And suppose these two are independent to each other. Okay. Now tell me what will be the distribution of x bar?
Mu1 minus mu2.
X bar.
X bar mu1. Mu1
square upon
sigma 1 square by
n1.
n1.
Right?
Yes.
I'm talking about only first sample. And what about y bar?
Sir, nu2 sigma 2 square by n2.
Sigma 2 square.
Correct. Clear to all of you? Now, if I will ask about x bar minus y bar, then what will be the mean of this x bar minus y bar?
Mu1
mu1 minus mu2.
Mu1 minus mu2.
Plus.
What about variance? Sigma 1 square divided by n1
n1
minus
plus
sir.
y plus.
You square it, so -1 becomes 1.
Correct. So please take care of this mistake. Okay. So this will be everyone for it's clear for everyone, right? Why it's a plus.
Yes,
First,
sir.
you will write variance of x bar minus variance of y bar, which will become variance of x bar plus -1 square variance of y bar, and this is sigma 1 square divided by n1 plus sigma. Now, okay, one more thing I will let me quickly cover that one. So if there is two sample test, then we have to proceed like this. Okay. So tell me, how will you go for this? What will be your test statistics?
It will be T, which is x bar minus y bar.
Okay. Let me come. Yeah, correct. Let me come to that. Let me explain one more concept, then I will come to that. Okay, suppose I explained you, right? N minus 1 s square divided by sigma square will follow chi square with n minus 1, right? This is the form, right? So can I write from here n1 minus 1 s1 square divided by sigma 1 square will follow chi square n1 minus 1 for the first sample?
Okay.
Yes or no?
Yes, sir.
Yes, sir.
And for the second, can I write n2 minus 1 sample variance of second sample and population variance is given for second sample? This will follow chi square with n2 minus 1?
Okay.
Yeah.
Correct? Or you can write S1 or okay. So there is one concept called for F distribution. I will come to that why I'm explaining that. If I'm dividing one chi-square variable, divide by that respective degree of freedom, and another chi-square variable, divide by respective degree of freedom. Is it clear? If I have one variable which is chi-square with n1 degree of freedom and I'm dividing with n1.
So degrees of freedom will be n1 minus 1, no?
No. See, it's not like always n1 minus 1. And this is in general I'm trying to explain here. Okay. So there is one concept called, if suppose I'm saying, see, I'm saying x follows chi-square with 2. It's possible?
Okay.
Right? So this just treat n1 as a true. Okay. This is possible. So I'm saying I have one chi-square variable and I'm dividing with n1 degree of freedom. I mean the respective degree of freedom, and divide by another chi-square variable divided by n2 degree of freedom. This will follow F distribution with n1 comma. This is concept. By using this, I have so can I write chi-square n1 minus 1 degree of freedom divide by n1 minus 1 degree of freedom chi-square n2 minus 1 divide by n2 minus 1. Can I write this as a f of n1 minus 1 n2 minus 1? No.
Yes, sir.
Yes.
Is it fine?
Yes, sir.
Now, what is the chi-square n1 minus 1 here? Chi-square n1 minus 1, that means I can write this one. Yes or no?
Yes, sir.
So, n1 minus 1 s1 square divided by sigma 1 square divided by n1 minus 1 whole divided by, and instead of chi-square n2 minus 1, I can write n2 minus 1 s2 square divided by sigma 2 square divided by n2 minus 1. Yes or no? I'm just substituting the value of test statistic. This will get cancelled out. What else you got? S1 square divided by sigma 1 square divided by s2 square divided by sigma 2 square. This will follow f n1 minus 1 n2 minus 1. Yes or no? Is this clear so far?
Yes, sir.
Now, so thing is, okay, I will come to that. Let me stop here for this. Okay, this will follow F distribution. Now, in case of two sample Z test, what we saw, what was the scenario? There should be x1 up to xn1. This should be IID, normal, mu1 comma sigma 1 square, and y1, yn2, IID, normal, mu2 comma sigma 2 square, right? And these to be independent. What will be your null hypothesis? Mu1 equal to
mu2,
and alternative is, suppose mu1 is not equal to mu2. See, it can vary. You can say greater than, less than, right? It will depend. Suppose I'm saying my t is defining as a y bar minus x bar because I'm dealing with two samples. Okay. So what will be my test? My test will be I'm going to reject my h naught if absolute value of t is greater than some c. Right? The similar way we can see in case of one sample test, my t was x bar minus mu. Right? Here it's a y bar minus x bar. Clear? Yes, no, it's fine,
Yes,
right?
yes, yes,
So
yes.
tell me, so this is absolute value. You can do x minus y bar. That's also fine. So what will the form of t? Tell me. I mean distribution of t. This will be normal.
Mu2 minus mu1.
Mu2 minus mu1. Sakshi, I just took one example. I think you have joined late for the p value. I took one example. I will share this PDF for p value. This is the p value. We have to proceed like this. So reject h naught. So t will be greater than. Normally we are denoting t is greater than c. So here we will take c as a this sample mean. Okay, 98.7, and we will proceed, and at the end we will find the value of p value. Okay, you can cross check.
Sir, is it alpha is a p-value?
No, alpha is not p-value. Lowest alpha is the p-value. Okay. So now let me come to this. See, I will come to that again. Don't worry. So this is test. I will reject h0. Then what is the usual procedure? I will start with alpha probability that reject h0 when h0 is true. So this will be probability of mod of t is greater than c. What is the h0? mu1 equal to
mu2.
So tell me what is the distribution of here t? Actually, basically, what you will do, y bar minus x bar or x bar minus y bar. This is greater than c, right? So what else you have to do? Basically, if you see the form distribution of t, so it's basically mu2 minus mu1 and sigma 1 square divided by n1 plus sigma 2 square divided by n2, right? So if you see, if you subtract this mean mu2 minus mu1, but under h0 it will be 0. Are you getting?
Yes.
See,
Yes.
y bar minus x bar is what? Y bar minus x bar, this follows normal mu2 minus mu1, comma, sigma 1 square divided by n1 plus sigma 2 square by n2, right?
Yes.
So if you see under h0, mu1 is equal to mu2. Let me write here. Y bar minus x bar is follows normal mu2 comma mu2 minus mu1 sigma 1 square divided by n1 plus sigma 2 square divided by n2. So if you see under h0, because we are taking this as a mu1 is equal to mu2, that means what? Y bar minus x bar will follow normal 0 comma sigma 1 square divided by n1 plus sigma 2 square divided by n2, or not?
Yes, sir.
Yes, sir.
Are you getting my point? So here what you have to do, you have to simply divide by this part only, square root of this part, and you have to proceed as usual. Correct?
Okay. Yes, sir.
Now, so this is something you have to do for normal test. But what if you have to test for two sample? You have to test the variance of two sample, right? We have seen the chi-square test for variance, right? Which was n minus 1 s square divided by sigma square follows chi-square n minus 1. But if you have two sample tests, right? So that's called F test. So two sample F test for variance. Okay, what is that? I will let me write. So x1 up to xn1. This is IID normal. Let's say mu1 comma.
So earlier one was two sample Z test, sir.
Correct.
Okay.
And
now
that was for mean, right?
Yeah.
This
So
is for variance.
Yeah.
So in case of variance, what will be my null hypothesis? Let's say sigma 1 is equal to sigma 2.
Sir?
Yeah. You can go with. That's not a problem. Okay, I'm just going with this. Not our just to you can go. That's not a problem. Let's say sigma 1 square is greater than sigma 2 square. Okay.
Yeah.
The few minutes before I told you what is the F test. F test is nothing but this part.
Sigma 1 square by sigma 2 square.
S1 square divided by sigma 1 square divided by S2 square divided by sigma 2 square is this part, right? So F test is what? It's test statistic is S1 square divided by sigma 1 square divided by S2 square divided by sigma 2 square. This will follow F N1 minus 1, N2 minus 1. Correct? Yes or no? This is something I just
Yes.
understood. But under H0, we know sigma 1 is same as sigma 2.
Yes.
Then what will be your test statistics?
S1 square by
Sigma square S2 divided by sigma square. This will get cancelled out, right? Because this is same under H0.
right.
So T will be what? S1 square divided by S2 square. Correct? Or else you can write sample variance for X first sample and sample variance for second. It's fine. That's not a problem. So when you will reject H0, I'm going to reject my H0 if T is greater than 1 plus CR, or I will explain you what
1
is the meaning
minus
of
CR.
this. Okay, don't worry, because this is in case of okay. So thing is, in case of F test, right? In case of F test, so F test is something like this. So this is something. Let me redraw. Okay, just treat like this. So actually, if you see this equation, can this exceed 1? No, right? Ratio can exceed 1 or not?
What is
Times
this?
it may be large, S2 may be large.
Okay, so this is 1 plus CR, critical region, and this is 1 minus CL. CL stand for lower critical region. Okay, so this is alpha by 2, and this is again alpha by 2. So I'm going to reject my H0 if it's greater than 1 plus CR or less than 1 minus CL. Actually, see, what about ratio? I'm talking about ratio. So this ratio can exceed 1 or not?
Yes.
No.
Maybe no,
Yes, it can.
greater than 1.
It can be
Exceed
greater, it can be lesser.
lesser, it cannot be greater.
Okay,
it can-
maximum should be what? I mean, usual, if you are talking about.
No, it depends on whether S1 is greater or S2 is greater.
Correct. So, yeah. So maximum, it will depend accordingly, right? Now, okay.
Yes.
Tell me whether this is clear. Why we are dealing with this like this?
Yes,
So
sir.
basically, you can think like this. Suppose I hold this line, and this is 1. Okay. So why 1? Because this will approximately 1 if H0 is true. That's why we are going with like this. Are you getting? So if H0 is true, right? Null hypothesis is true. So null hypothesis is true means you are saying
Sigma 1 equals to
variances are
sigma
same,
2.
right? So that means it will be approximately 1. So that's why we are going with 1 plus some value and 1 minus some value. So if your values will be lie here, you will reject H0, and if value will be here, you will reject H0. And for this region, I'm going to accept. Clear? So basically, you can think this is your CL, 1 minus CL, and this part is CR, some value. Okay? And uh, for and how to proceed first of all for a given H0. Okay, so my T will follow first of all N1 minus 1 and 2 minus 1, right? So as usual, we are proceeding with alpha, right? So here we will proceed with alpha by 2 because of probability T greater than 1 plus CR, given that H0, or else I can say alpha by 2 is probability T is less than 1 minus CL, given that H0. So probability of rejecting H0 when H0 is true. This is rejecting H0 when H0 is true. So we are dealing with alpha by 2 here, because I will reject
Symmetric.
yeah, not a symmetric.
Sorry, means both will be equal.
Both will be included. Okay. Okay, fine.
Sir,
So,
the curve is not symmetric, no, sir. Distribution.
no. Curve is
No.
not symmetric. Curve is not
Correct.
symmetric. Yeah.
So, so, but the area.
That's why that, yeah. Actually, it's not properly drawn from my end. So
No, that's okay, sir.
huh.
You don't have to draw it exactly, but on the left side, on the right side and left side, will it be always equal alpha by 2 and alpha by 2?
Yeah, alpha is what, right? Yeah, that's why alpha is what? You have to consider both sides, right? So either if alpha by 2 is this side on right hand side, right?
Correct,
Or
sir.
alpha
No,
by 2 is this side.
sir,
Then
in case of normal distribution, okay, we know on both sides it is same, and so if on the right side it will be alpha by 2 and left side it will be alpha by 2, but this is not a
Both,
uniform. This is not
both.
a,
Correct, correct. Yeah, yeah. Good, good.
yeah, because this is not a symmetric distribution is not symmetric. So will it be alpha by 2 on the left side and will it be alpha by 2 on the right side?
See. So total, first of all, total, like see,
Total alpha is
total. Yeah. Good.
So total rejection region is alpha. Okay, which is equal to the probability of rejecting when t is greater than c plus 1 plus cr
1 plus cr. Yes.
Plus probability of t less than 1 minus cl.
Yeah. So 1 minus cl and 1 plus cr. Correct.
Correct. Now, will they be equal? That's my point.
Yeah,
we take
your voice is
We
breaking.
take CL and CR as such that the code
accordingly. We take CL and CR accordingly so that it becomes equal.
We take it in
Yes,
a way
CL
that
and
the
CR
data
are
will
not
become
equal.
same.
One second. Don't worry. Let me take one question. Then we'll try to understand. Okay. Suppose I'm saying x1 up to x30. Okay. Let's say this is IID from normal mu1 comma sigma 1 square. Okay. And I have another sample y1, y2, y25. This is IID normal mu2 comma sigma 2 square. Okay. Then I just assume these two are independent. I'm saying S1 square is given to us. First sample is, let's say, 11.4 and S2 square is, let's say, 5.1. So question is, what conclusion would you make for F test to check the null hypothesis sigma 1 equal to sigma 2, and alternative is, let's say, sigma 1 is not equal to sigma 2. Okay. So tell me, okay, so you have doubt about this part, right? 1 plus CR and 1 minus CR. Okay.
Yeah,
So
correct.
okay. Let me show you the graph of F distribution. Okay, maybe that will give you the idea. Okay, don't worry.
Sorry, sir, to interrupt you. Just very normal, sir, question, sir. I just want to know because, sir, as told by you, the number of questions from week 1 to 8 will be very less, sir, around only 3-4 questions, sir. Majority will be from week 9 to 12. I just want to know, sir, because some lack of some time, sir, if I go for a week, because the number of questions will be very less, the PYQ will be sufficient for, in your opinion, sir, for week 1 to 8?
Yeah. Correct. PYQ is there.
1 to 8, that will be sufficient, sir?
Yeah. But I would suggest cover the major topics. Okay.
Because sir, week 9 to 12, I will cover everything, but for paucity of time.
Yeah. Do the PYQ. That will give you some idea. Anyway, all the formulas it will be given to you. So basically, you have to go with the concepts, right?
Okay. Yeah. Thanks, sir. Thank you.
Yeah. So now, can you see the PDF of the F distribution here?
Yes, sir.
Okay. So that's why we are taking. Suppose one is what? One is here. Can you see my cursor, right? So so CR will be such that and CL will be such that it should give you the alpha by 2 on both sides, and if 1 plus CR is greater than and 1 minus is less than 1 minus CL, then you will reject. Fine?
Okay.
Are you getting some idea? No. So actually, suppose, so you can see for different degree of freedom, you are different kind of, let's say this blue curve. Okay. For blue curve, one is here.
Yeah.
Right?
Yes, sir.
So your CR will be such that your alpha by 2 will be here, and CL will be such that alpha by 2 will be is this area.
Okay.
Are you getting my point? So
Yes,
here I'm not able to.
So both CR and CL will get adjusted such that the area under the curve on the right side of CR and the area under the curve on the left side of CL will be same.
Alpha by 2. So actually the graph should be like this. It should be something like, suppose 1 is here and CR is here and CL is here. Something like this.
Yeah. Okay. Understood.
Okay. Okay, so if anything is missing, don't worry. If you are interested, we can come up with some coding example if you are okay with that after the end term. If you are interested, otherwise it's okay.
Sure, sir.
Okay.
Yeah, sure,
Okay,
sir.
so how will you proceed? So basically, I told you, right? So I'm taking alpha by 2, right? Because I'm going with OR procedure, right? Not with AND. This is the difference, right? You will reject when this is true or this is true. Okay. So I can go alpha by 2, probability that T is greater than 1 plus CR. Okay. Or else I can go with uh, alpha by 2 is equal to probability that T is less than 1 minus CL. So anything I can proceed with that. So let's go with this. So how will you do? So alpha by 2, probability T is greater than 1 plus CR, some value. So to convert in a
1
CDF
minus.
from, so T is less than 1 plus CR, alpha by 2,
Yeah.
right? So based on this, can you tell me how many? So this is 30, this is 25. So this will follow basically. So here, can you tell me S1 square divided by S2 square will follow F distribution with N1 minus 1, that is 29. N2 minus 1, that is 24.
24.
So that means what should I write? So alpha by 2 equal to 1 minus F uh, 29 comma 24 1 plus CR, because T is what? This I'm dealing with this part. Okay, clear?
Okay.
Yes, sir.
So this will be F 29 comma 24 1 plus CR 1 minus alpha by 2. Actually, it should be not, it should be something like this. One second, let me correct it. It will be CDF of F distribution. Clear? It's fine. Are you okay with notation? See,
Yeah.
we are writing FZ, right? So instead of Z, it's a CDF of F with 29, 24. Clear? So
Yes,
this
sir.
will be, let's say alpha is 5%, so it will be 0.05 divided by 2. So I will write F1 plus CR equal to F inverse of F 29 comma 24 1 minus 0.05 by
Excuse me,
2.
sir. Sir,
So
one if
some
it
value will
goes
be
other.
given.
Sir, one if it goes other side, it will be alpha by 2 minus 1, not 1 minus alpha by 2.
Reverse
See,
it.
1 minus, it's correct. You have to do here and alpha by 2 will be there. It's correct, right?
Yes, sir,
Yes.
it's correct.
Okay. Or else, okay, so tell me, how will you proceed? So suppose 1 plus CR is coming out to be 2.217. Just assume, okay? Just assume 1 plus CR. And what is the value of S1 square? It's given as 11.4 and S2 square is given to us 5.1. So we have to check. So S1 square divided by S2 square is greater than C or not? Are you getting?
1 plus
So
CR.
11.4 divided by 5. Yeah, sorry, correct. So whether it's greater than 1 plus CR or not. So this value, what is the value of this? 2 point something. Can you calculate?
2.235.
23, right? 235. Okay. So this is greater than 2.217, right? So that means what? You will reject your H0. Correct? See, for single sample test, what we saw, S square is greater than C square, right? We will reject H0. To double sample test, S1 square, S2 square is greater than 1 plus CR. Or if you are dealing with 1 minus CL, so it should be S1 square divided by S2 square, it should be 1 minus CL. Sorry, it should be in reverse order.
Less than 1 minus.
Less than 1 minus CL. Okay? Then you will reject H0. Is this clear?
Yes.
Okay, if
Yes, sir.
you're not getting, don't worry. So uh, anyway, it's not okay. Now tell me about answer of this question. So from week 12, again I'm saying there is a very
Sir, you can
basic
try to
question.
hide the answer.
Sorry. Okay.
Yeah.
Yeah. Thank you.
Yes, sir.
First one wrong.
First one.
Wrong.
Wrong. Wrong.
First one is wrong because it should be
Plus.
plus. See, if this concept is clear, I can assure you, you will get some marks. Okay. So anyway, I'm giving you idea. Now, what about second one?
Right.
Right. Correct.
Correct.
What
Right.
about third one?
Right.
Correct.
Correct.
Why not fourth one is? Because it's n minus
minus
n1
one.
minus 1
N
n2
minus
minus
1.
fine. So B and C is correct. Okay. Now, okay, I think that was the last question. Okay. So someone had a value regarding P, doubt regarding P value. So P value, we have to start like this: reject H naught when H naught is true. So we will check when normally we are saying T is greater than C. I mean, if it depends on the null hypothesis. Null hypothesis left hand side, I will go with this. So since we are dealing with P value, so instead of C, we will check whether my test statistics. I mean, so thing is, what is the P value? I'm going to find the probability that whether my test statistics is greater than this, whatever the we have observed sample mean under H naught. I will find some P value and I mean that will be your answer basically. Okay. So you have to do basically probability that T is greater than the given C, which is sample mean. Okay. So I think we have covered more or less everything. Okay. So all the very best to all of you.
Thank you, sir.
Sir, I had one doubt, sir.
Yes, sir.
Yeah,
We have
yeah.
checked from tests given.
Hmm?
So in last question,
Hmm.
so
Yeah,
we
go
are
ahead.
testing from given test cases.
We are
So that given test formula we have, from that we can get the answer of the last question.
no, if I'm missing something, can anyone explain? I'm not getting your point.
So last question you explain, no?
Huh? So what is exact doubt like?
So how we get the answer by that formula given to us in the exam?
Which
That
answer?
test cases, Z test and all.
No, which answer you are talking? You are talking about this answer, or you're talking
No, no,
about
sir. That,
huh?
sir, that last question you.
Sir, you showed us one question where we had four options and you tried to evaluate. I think he's talking about that.
This one, huh?
Yes, sir.
Yes, that's what he's talking about.
So what is your doubt? You are saying whether you can find this from test formula set, huh?
Yes, sir.
That's your smartness, right? Okay, if you know the things, that's very good. Otherwise, see, I'm not saying everything will be in formula set. So formula set is for your help, right? If you don't know any formula and all, so here, see, smart approach is you can see for difference, your variance should be summation, right? But here it's negative, it's incorrect. Or else, if you know the concept, you can go with this. You can see smart approach is it's a chi-square n minus 1. So you can check whether chi-square n minus what is chi-square n minus 1? N minus 1 s square sigma square chi-square. So that's a
Yes,
smartest approach, right? That
sir.
it depends on you how to approach. Okay, it's not
Yes, sir.
if you
That's the
remember.
point I am asking.
Yeah. So I think you should mention. I have to change the PDF. I was searching in that PDF. Okay, but not a problem.
Excuse me, sir.
Huh?
Sir, I had one doubt in that alpha by 2 question, sir.
Yes. Go ahead.
Sir, the previous one, that alpha thing.
Uh-huh.
Sir, in this step, sir. No, a little bit down, sir.
Okay.
A little bit down, sir. Sir, we just shifted that one towards the left hand side, no, sir. Like, did we send the entire thing towards that side, or we just took alpha to the other side, sir? Alpha by 2 to the other side.
So alpha by 2, you can go with either one. Okay, you can proceed with this also. You can proceed with this also. If you will
Sir,
add
not
those
that
two,
one, sir. Sir,
this one.
I understood. Like,
This one.
I understood. No, sir. You just shifted that alpha by 2, 1 minus alpha by 2.
Okay,
No, sir.
that side, huh?
Yes, sir.
Okay. So you had doubt here. So see what I wrote alpha by 2 equal to 1 minus f something, right?
Yes, sir.
So what else you can write? Can you take f this side?
No, sir.
No, why not?
Sir, we can send one that side and write 1 minus alpha by 2, and then again send the negative
Yeah,
side.
yeah. So
Negative side.
anything see, I
Whatever
can
is
do.
the same result now,
See, I can do like this, right? And then
Yes.
I can take minus on both side, and then this will be minus. Like basically, I can one second. See, this I can write like this. So if you'll take minus on both side, okay,
Yes, sir.
minus or minus f, this will be minus alpha by 2 plus 1 equal to f. So this is again f equal to 1 minus alpha by 2. Okay,
Yes, sir.
the same thing I did. Okay.
Yes, sir.
Sir, in this T came out to be greater than 1 plus CR.
Ha.
So we rejected H naught.
Correct.
So if T would have been less than 1 plus CR, then?
Then
No,
you check with. Then you also check with
1 minus CL.
CR, and if
1
it is
minus.
less than 1 minus CR, still you can reject it.
So
Otherwise,
actually, see, one second. You have to go with this. Okay. So if it's 1 plus greater than 1 plus CR, you will reject, or it's 1 minus less than 1 minus CL, you will reject. If it's in between, you will accept. So then basically you can go with both approach. Then okay.
We have to check both.
Correct.
If suppose T is less than 1 plus CR, then we'll check for the other one also.
Correct.
T.
Correct. Ha.
Okay.
Okay. All right then.
Sir,
So I think yes. Yeah. Go ahead.
so that question which I mentioned in the beginning, I got regarding the company ka thing which you said it might be a two test ka problem. Yes, sir. That one it's actually from a lower statistics course, like less easier one. So I'm thinking it's not that hard. Is it possible for you to solve it now? Like I can copy paste it in the messages.
Okay, it's not about easier and deeper. Yeah, yeah. Okay.
But I
just,
don't think it's a two test ka problem.
okay. Can you type in chat?
Yes, sir. I'll
Rather, I mean, if it is put on discourse, everybody can look at it.
Acha. I'll do that after the meeting.
Yeah, that's also fine. We can have a great discussion there also. That's not a no.
By the way, whatever you discussed today, that PDF you will be sharing. How you will be sharing?
Yeah, so I will share with the support team. Okay, and they will upload by tomorrow. I don't think tomorrow. Sorry, tonight they can do. Okay.
So can you share it on discourse anyway as a link?
Yeah, fine. I will do. Okay.
Yeah, so we can.
Okay. Okay, I will.
Thank you.
Yeah. So,
Sir, this is not a doubt for stats too. I have taken another subject, math too. Also, I am not able to access the discourse for it. I don't know the weightage. Can anyone here who has taken maths too? Can you please tell me what's the weightage?
Yeah, I think you know because I'm not aware about the weightage of maths too.
Anyone else in this?
Yeah, those who are aware can. Yeah, okay. So question is, you can perform G test actually. I think I can read your question. So your alternative, if you're talking about training program has improved, so it can be your mu is greater than 65 actually, because that's your you're suspecting that, right? You are initially saying it's a 65, and now you are saying based on sample values, it's a greater than that, right? So it will be mu is greater than 65. Yeah, correct. You are right. Actually, maybe I'm confused while I just. And now I read it. It's correct. Yeah, thanks.
It should be Z test, sir.
Yeah, it should be G test because mean is given to you.
Correct.
Right?
Mean is given and variance is also given.
Variance is also given. I mean, mean you have to test for mean, and
Correct.
variance is given to you. And I think you have to. It will be rejected because I can see the values. It's 68 minus 65, right? Which is 3. Divide by, if you see sigma by root 10. So where it went? So sigma is 4, right?
Yes, sir.
And root 10 will be 1 square root of 125, which is
5 times
5 root 5, and which is, I think it's coming out more than 3 if you divide. So it will be rejected as my as I can do the calculation. Yeah.
Again, the null is that the
mu is 65.
Mu is equal to 65. The alternative is that it's greater than 65.
Correct.
Thank you. Thank you, sir.
Okay, all then, everybody. So that's end for your stats to core. From my side, there will be mock session, but most probably I will not be available for that. Maybe other instructor will take. So thank you to all of you.
Thank you so much, sir.
Hope you
Sir,
enjoyed
sir.
stats to journey.
Thank you, sir.
Yeah, thanks.
And
Thank you very much for all your encouragement and patience, sir. Thank you.
Thanks. The only thing I can hope you have learned something from statistics 2 course.
Definitely.
And
Yes.
if is there anything you any kind of doubt you have, you can simply tag to us on this course. We will be available anytime, right? Even you are doing other courses and all. Okay, so if you have any doubt and all, so most probably I will meet you in degree level courses because I'm teaching some courses
Sir,
there.
what is your ID if I want to tag to you in
Prasant to something.
Prashant? Okay.
Prasant.
Okay.
Yeah,
Sure.
you can find that one.
Yeah.
So so that's all. So all the very best to all of you. Okay.
Yeah.
And
Thank
I
you, sir.
hope you will pass with some flying color.
Yep.
Thank you.
Thank you so much, sir. Appreciate that.
Yeah. Thanks. So.
Thank you, sir.